question 1, a to h, we have done already, but let us do it together quickly here. What is a limit of f of x when x approaches -1? -1 is this value, right? If limit here, it approaches, what is it, what?
Is it 1?
Perfect.
Why is it 1 and not 2? Because like
it is the limit. At f, we see that from the graph, f of -1 is equal to 2, according to the graph here. But the limit, it means that when x come closer and closer to -1, -1 is right here, then f of x will follow this path, right? Go to this one here. If x is smaller than -1, if x is larger than -1, it will follow this path and come closer to this point. And this point, the value of this, according to this graph here, will project to this point. It is exactly 1 right here, this point. Okay.
Hey.
You're welcome. Then, what is the limit when x approaches 2 from the left? 2 is right here, right? And limit when f approaches 2 from the left. Thank you, Isaac. Then it follows this path, right? If x come closer and closer to 2, the path we are following is this range. It approaches to this value, and we project it into y direction. It will be exactly 4. Is it clear what? Good. How about if x come closer and closer to 2 from the right-hand side? Yeah, it followed this path, you see? Thank you, Isaac. It's going back to this point here at 1, right? Do you see it? Here, if x come closer and closer to 2 from the right, this is the function value, function f of x, the graph of it. We'll follow this path and go closer to this point, which is 1, right? We see that in this example, the left-hand limit and the right-hand limit when x approaches 2 are different. Therefore, what is the limit when x approaches 2? That's correct. Thank you, Isaac. Since the left-hand limit and the right-hand limit are different, then the limit does not exist when x approaches 2. Very good. And according to the graph here, I just ask you a random question. What is f of 2? This guy, the solid dot. Thank you, Isaac. It is 1, right? Very, very good. Excuse me. Here, the limit when the function f of x here, limit of the function f of x is x come closer and closer to 3. This is 3. At x is equal to 3 is this vertical line. Okay. As x come closer and closer to the left, the function will follow this path and go up to a very large number, right? If x come closer and closer to 3 from the right, it should follow this path here, go into very large number, or in general, we call it infinity, right? Okay. And the horizontal asymptotes. What is the limit of the function when x goes to a very big number? x becomes very big, it follows this path here, right? And become smaller and smaller, and you see that it is approaching 2. Thank you. Perfect. Then 0, I mean 0. It is 0. The same things. If x go to negative infinity, follow this path and come closer and closer to 0. Okay? Are we good? So this part, we've done it very well. Then the next question, where is the graph f of x discontinuous? Where is it? This point, this is a removable discontinuous, right? Let me just erase the previous things so that it won't confuse you. Okay, it is discontinuous at this point and at this part, right? When x is equal to 2, and at here x is equal to 3. So there are 3 different points that is discontinuous. Very good, thank you, Isaac. So it is discontinuous at x is equal to -1. And this one, so if we define a value at -1 by 1, like we have just done before, right? Then it becomes a continuous function. That is why we have the name removable discontinuous. We can remove by defining the value, function value. If we define f of -1 is equal to 1, then this function is continuous. But in this case, it is a removable discontinuous. So in the exams, you can simply, okay, at x is equal to this, it is removable. It's fine. Very good, thank you. And at x is equal to 2, at x is equal to 2, if x goes from approaches 2 from the left, the graph will go to this point, but then it jumped down, right, and continue. So that is why it has a name, jump discontinuous. Okay. At x is equal to 3, limit of f of x goes to infinity. Therefore, at x is equal to 3, it is infinite. Discontinuous. That's it. That is for the question I. Okay. What are the vertical and horizontal asymptotes of this function? When we go back to the definition of this, the vertical asymptotes is when the limit of f of x approaches a point is equal to infinity. We call it a vertical asymptote, right? From the right or from the left or something like that. Go back to the definition yourself, review it. But in this case, we know that where is the vertical asymptote of this one? Thank you, Isaac. It is this line, right? This is a vertical line, and this line, it is the graph of x is equal to 3. So it is a vertical asymptote. And the horizontal asymptotes is when we compute the limit of the function as x approaches positive infinity, right? And in this case, it is approaching to 0 in this case, right? And negative infinity. So therefore, it has the two horizontal asymptotes are just the same one. Therefore, it has only one horizontal asymptote here. Yeah, not a good draw, but you see it, right? This is the x-axis. So in the exams, you can write vertical asymptote. It is the equation x is equal to 3, and horizontal asymptote y is equal to, what is it? And you can just observe the graph of this and conclude. Very good, because we are not given a clear definition of f of x. This is given in the graph, and we know it. So y is equal to 0. Okay, that's it. Remember, vertical asymptotes is a function of x is equal to something. Horizontal asymptotes is the function of y is equal to something. That's it for the question 1.